yp1. So it is a sum of two different particular solutions, and this is a second function. So I can call it as yp2. Okay, now we will determine the complementary solutions. The complementary solution here is, you can definitely see that auxiliary equation becomes m square minus 2m minus 3 equals to 0. Suppose it is a 0. So if I factorize it, it becomes m square minus 3m plus m, that is minus 2m, and that becomes, yes, this factorization is true, and m into minus m minus 3 plus 1m minus 3 equals to 0. So here m1 is minus 1 and m2 is 3. So that means I have found two distinct real roots. That is basically case 1, that falls into the category of case 1 of the complementary solutions. So yc is c1 e to the power minus x minus 1 into x plus c2 e to the power 3x. So here is the complementary solution. Now we come to the point at, so yp is of two types. It is a sum of two different functions. So we solve it separately and then we will find out the values. So first of all we will solve. Let yp is yp1 is, because it is a linear function, so you have to replace ax plus b and yp2 side by side. I am supposing it and we solve it separately. So yp2 is 6x e to the power 2x. So 6x is also linear. It is basically a product of two. One is linear multiplied by exponential. So I have to replace something, and e to the power 2x. E to the power 2x is like this. So I will do these derivatives accordingly. So yp1 dash, first derivative, is ax plus b. That means a, and also yp1 double dash is 0. Okay, and then yp, it is a product of two functions. So first is cx into e to the power x. Cx e to the power x. You can also write it as cx e to the power x plus d e to the power 2x. And then I will check the derivative, first derivative of these two terms. And first you have to take the derivative. Product rule is applicable here. C e to the power 2x plus what? 2 into cx e to the power 2x, because e to the power 2x has derivative 2. So the power has derivative 2, so that is going to say that. And also it has 2d e to the power 2x. That is first derivative. And the second derivative of this is again a product rule. So we are just doing here if it is applicable. So yp2 is 2c e to the power 2x and 2d. 2d means 4d e to the power 2x, and this in the middle term, or in the second term, we are using the product rule. And for the product rule, that is first term is x and the second term is e to the power 2x. So first x has the derivative 1, so that becomes 2c e to the power 2x plus 2x. 2cx is now one term and the second term is e to the power 2x, so that becomes 4 visible for 4cx plus 4cx plus into e to the power 2x, and we can add these two terms because these are same terms. So yp dash yp2 dash yp2 double dash equals to 4c e to the power 2x. I am just adding these and this term. First and third term is added to have this term plus 4d e to the power 2x plus 4cx e to the power 2x. So here is the second derivative. Alright, now I am one by one I will solve this because yp1 is also a particular solution, so I will replace it into this equation. So I have to change the direction so that you can see properly. Y double dash minus 2y dash. Y double dash minus. So yp1 double dash. Yp1 double dash is 0. So that is 4. Yp1 0 minus 2 into yp dash. This minus 2a minus 3ax plus b equals to 4x minus 5, because we are doing it separately, so that is 4. Okay, minus 2a minus 3ax minus 3b equals to 4x minus 5. So first of all, I will compare the coefficients of x. So compare x, it becomes minus 3a equals to 4. So here a is minus 4 by 3. And also compare the constants. Compare constants. So that becomes minus 2 into a minus 3 into b equals to minus 5. So here I am just replacing the value of a. Minus 4 by 3 minus 3b equals to minus 5. That becomes plus 8 by 3 and minus 3 into b equals to minus 5. So do the algebra, simple algebra, that makes it minus 3b minus 5 plus 8 by 3. So minus 3 into 5 LCM minus 15 plus 8 by 3. If you can see minus 15 plus 8 by 3. And minus 15 plus 8 is minus 7. This is minus 3b. So 3b is 7 by 9. Is ax plus b. So I am replacing the value of this. A is minus 4 by 3. X plus b is 7 by 9. Okay, so yp2 double dash is 4c e to the power 2x so yp2 is 4c e to the power 2x plus 2c 2 into c e to the power 2x plus 4 into d e to the power 2x. So that is yp double dash, and minus 2 into y dash. So yp2 dash is c e to the power 2x plus 2 into d e to y. Minus 3 into yp2. That means yp2 is cx e to the power 2x plus dx e to the power is equals to 0. Okay, solve it. 4c e to the power 2x plus 2c e to the power 2x plus 4d e to the power 2x minus 2c e to the power 2x minus 4d e to the power 2x minus 4c x e to the power 2x minus 3c e to the power 2x minus cx minus 3d e to the power 2x equals to now I can see that you can add the same values. So because there are two dominant terms, you have to compare the coefficients of those dominant terms. If you can see that there are two dominant terms, that is one is simple e to the power 2x and the other one is along with the x e to the power 2x. So you can compare the coefficients of that variable. So if I compare e to the power 2x, that becomes, if you can see that, if I compare 4c e to the power 2x plus 4cx e to the power 2x plus 4d e to the power 2x. So that is yp double dash minus 2 into yp. Yp dash is c to the power 2x plus 2 into d e to the power 2x plus 2 into c into x e to the power 2x, that is first derivative, minus 3 into cx e to the power 2x plus d, that is simple yp2. So you can replace it equals to 0. Now there are major two constants of these two terms, all three terms. So I'm just writing it and solving it. 4c e to the power 2x plus 4cx e to the power 2x plus 4d e to the power 2x. So I am just comparing because there are two major coefficient variable dominant terms that the coefficients can be compared. So first is e to the power 2x, you can see that, and second one is you cannot see that, that is x into c to the power e to the power 2x. So first of all compare the coefficients of e to the power 2x. So that becomes 4c and also plus 4d minus 2c minus 4d and minus 3d equals to 0. So that becomes 4c minus 2c. That becomes, I'm writing yc here so that I can solve it. Okay. So 4c minus 2c, that becomes 2c, 4d minus 4d. So that becomes minus 3d equals to 0. So that means c equals to 3d by 2. So comparing the coefficients of x into e to the power 2x, that becomes 4c x into e to the power 2x and also minus 4c minus 3c. Okay, for yp2 we have to compare this one, right? So first of all, yp2 dash is yp2 double dash is 4c e to the power 2x plus 2d e to the power 2x plus 4cx e to the power 2x. So I am replacing here for second derivative minus 2 into yp2 dash, that is c e to the power 2x plus 2cx e to the power 2x plus 2d e to the power 2x. So I am replacing here, and also minus 3 into yp2 Simple. So that is cx e to the power 2x plus d into e to the power 2x equals to 6x e to the power 2x. Alright. Then we solve it accordingly. Minus sign, if it is multiplied, minus 2 plus 2, that becomes 4, 3, and all the coefficients are multiplied and arranged in this form, and that becomes minus 6x e to the power 2x. Okay, also here is 6. Okay. So if we solve, c becomes minus 2. Yes, c becomes minus 2. And if I replace this in this form, then it becomes minus 2 equals to 3d by 2, and d becomes minus 4 by 3. So d becomes minus 4 by 3. So what I am going to do, I am just replacing the value of c and the x, and d is minus 4 by 3. So this is the solution. Solution is yc plus yp1 plus yp2. So if I am erasing this, and also this one yp1 plus this one yc. So solution, general solution becomes now y equals to c1 e to the power minus x plus c2 e to the power 3x, that is complementary solution, plus particular solution number 1, that is minus 4 by 3x plus 7 by 9, plus yp2, that is minus 2x into e to the power 2x minus 4 by 3 e to the power 2x. So I hope that you all understand this video. It is in complete detail, and if you have any questions, you can ask me in the online lecture. Thank you so much.